Hello ladies and gentlemen. I must sincerely apologize for my glacial rate of video uploads. I assure you that I am very, very busy during the week. I'm not just twiddling my thumbs and playing video games or doing crochet, whatever you imagine I do in my spare time. Oh, I left my hair elastics on there. Whoops. Now, today I'm going to do some experiments. It's in the past for me, of course. Where I'm trying to track down this weird 20 microsecond delay. Is it caused by the sample rate? So 1 over 48 kilohertz is indeed 20 microseconds. So if I change the sample rate, do I change the delay? I'm going to show you the experiments and catch up with you soon. In episode 6, I stated that the time delay was probably caused by the codec chip and some design fault there. However, I don't really know that, and that was just an assumption. So I thought I would test that today by playing with the project rate. So I've gone ahead and generated an in-phase signal. This is 14 kilohertz, and it's just the same on the left and right channel. You'll notice the project rate is 48 kilohertz. Track 1 is all the way to the left, track 2 is all the way to the right. And if I hit play, you can see we have our famous 20-second time delay. So what happens if we change the project rate to a different value? So let's try 88.2 kilohertz. Let's try a lower rate, 44.1 kilohertz. And it doesn't seem to be changing. Well, okay, let's try and generate the signal at those lower rates. So I'm going to change to, let's say, 44.1 kilohertz, then go generate, tone, 14 kilohertz, amplitude of 1, and it's a sine wave. I just asked for a 30-minute duration. So now we have a stereo track, so you can see it's the same effect if I play it there. But just to make sure this is a fair test, I'm going to copy this track. So now we have two aligned tracks. So they're both operating. I'm going to set track 1 to the left and track 2 to the right. And now we have our signal again. But once again, we have 20 microseconds. I'm just going to cut myself off there. I tried various combinations of sample rates and frequencies, etc., and I couldn't really shift the 20 microsecond delay. No matter what I did, it was always 20 microseconds. So I'm going to skip ahead in my experiments until I did actually change that. I was reading the Audacity forum, and there's something that they describe as an interface, by which they mean some kind of software layer of the interface. And they present these three options: MME, Windows Direct Sound, and WAS API. And there's also something called ASIO, which I was recommended. However, I've learned that I can't use this with my version of Audacity, so I'll have to look into getting some other software to do that, which I might do in a future video. But just for fun, I thought I'd compare them. This is MME, which is what I've always used. So that's pretty normal. If I change to Windows Direct Sound, whoa. That is really bizarre. It's like it's really compressed. I don't understand what's going on there, but that is not what it should look like. That's just crazy. I have no idea why it's so bad. So let's try WAS API. That looks okay. And I also have this other option, WDMKS. And I have no idea what to make of this. That also looks okay, although interestingly the delay seems to have changed. So we're on 30 microseconds? That's really bizarre. I've put it back to 2 separate tracks. So let's try going back to the 44.1 kilohertz. Let's go generate tone. Leave it on 3 kilohertz. Yeah, that still looks to be about 20. Let's try the higher ones. So 384 kilohertz, okay. Let's see what that does. And just because this is a higher sampling frequency, I'm just going to turn the duration down to 5 minutes. So it should be quite a clean sine wave with a strong oversampling. And once again we're on 20 microseconds. So if I go and duplicate this track and go left, right, let's do 1 sample, and in theory this should not be enough. So yeah, that wasn't enough. You can see that there's still a delay there. Let's go 1, 2, 3, 4. I think that was 4 sample periods. And now we're down to 10 microseconds delay. Let's go 5, 6, 7, 8. And now we're dead on, no delay. So I just changed to WAS API, and it's also fine. Windows Direct Sound, and it gives me an error, thank you very much. So that's okay, it can only do certain sample rates, that's fine. MME, ooh. So we have some kind of periodic error there. That's unusual. That's all the experiments I have for you today. I hope you enjoyed. We didn't really come to a satisfactory conclusion, and as with so many things, we're left with more questions than answers. I quickly whipped up this very technical diagram in MS Paint. You'll see this if you search for how does an embedded system really work and how does the hardware and software connect. Although really, this is not an embedded system, that's just what my experience is. So that's kind of how I think. So how does this work? Well, we have an application which is Tenacity, and that's using some kind of API, so application programming interface, to talk to a driver, which then talks through some kind of abstraction layer to the hardware. So HCL is hardware access layer, I think, or hardware abstraction layer. Who cares? These are just sort of bridges. And what's really changing our performance is going to be the application. So what are we asking it to do in Tenacity, Audacity, and the driver? How does that then get implemented in the commands? And those commands are going to do something to the hardware, the physical high and low signals, the ones and zeros in the box. Could I change the software to use the ASIO drivers, which are supposed to be low latency? That might be one direction. I'm going to be honest, I'm a bit hesitant to do that. I don't really like messing with drivers because Windows is a bit of a sensitive beast, and I'm sort of scared to go down that route. Now, I could try to change the drivers, so that would involve changing the application, unfortunately. But that's still another potential route of inquiry, or inquiry, whatever. Now, another possibility, and spoiler alert, this is the next video, what if we change the hardware? So the drivers that we have are the plug-and-play drivers that come with Windows. I never installed anything for my Behringer. I just plugged it in and it worked. So if I can get another audio interface, so some different hardware, which is plug and play, those drivers, we would think, would be equivalent or perhaps the same. Now I'm saving that for the next video. Thank you all very much for watching, and goodbye.